From the bobsled run, to the curling house, to the skating and hockey venues. For hundreds of Winter Olympic athletes, the competition heats up on a cold, hard place, the ice.
Ice is a really fascinating substance, and we're very lucky as humans that it has such interesting and strange properties.
Ken Golden is a mathematician at the University of Utah. With funding from the National Science Foundation, he has traveled to Antarctica to collect data on sea ice for climate studies. Golden explains it's the unique surface of ice that makes the slide and glide of winter sports possible.
We can run metal blades over the top of it, and that's being made possible by the slipperiness of the surface of the ice.
Why is ice slippery? The answer begins with water molecules, made up of an oxygen atom bonded with two hydrogen atoms. The oxygen end has a negative charge, and the hydrogen end has a positive charge. The opposite charges attract other water molecules like magnets and form what are called hydrogen bonds. Molecules in liquid water move about closely, and the hydrogen bonds are made and broken easily.
As water approaches the freezing point, the water molecules will slow down. They're not bouncing around as much because there's not as much thermal energy in the system.
As the molecules slow down and the hydrogen bonds begin to hold, they form into rigid hexagonal or six-sided groups that connect into a structure called a crystal lattice.
And then these patterns are repeated on many different layers.
As ice thickens, the bonds within the structure form in all directions, locking in place and making the ice hard. Surface molecules, however, can't form rigid bonds above them and are in a loose quasi-liquid state, also called pre-melt. Under a hockey puck or a skater's blade, this layer acts like a lubricant that allows almost frictionless movement over ice, just what the athletes need to glide.
A lot of it here that we're concerned about is the quick and the speed of the ice. So anything that's going to draw on that or create a problem for that, we try to eliminate.
Todd Porter is facility manager of the Utah Olympic Oval near Salt Lake City, home of the 2002 Winter Olympic speed skating events and where the 2014 U.S. Olympic speed skating team trials were held. Porter oversees the production of the glass-like ice sheets essential for hockey, figure skating, and speed skating.
When you're talking about ice and creating the fastest, best quality for any athlete, the number one thing is cleanliness. Any dirt or sediment or anything that's on the surface or throughout the ice is going to dull blades.
The water for all the ice surfaces at the Oval first goes through a filtration system that removes impurities before being applied to a concrete slab. The refrigeration plant sends a cold brine solution or salt water through pipes in the concrete. Why brine? Salt ions keep water molecules apart so they don't form hydrogen bonds as easily to become ice. That means salt water freezes at a lower temperature than fresh water. The brine solution chills the slab so the layers of filtered fresh water put over it will freeze solid.
So that system allows us to create a nice clean surface that has a really good strong bond but also has a fast surface.
The thicker the ice is, the greater the distance between the freezing brine and the ice surface. So thicker ice means a warmer and softer surface.
I'm not super picky about my ice when it comes to exact temperature and feel, but soft and clean is my favorite.
For figure skating, hockey, and short track speed skating, the ice is about 1 inch thick, but ice surface temperatures are different, creating the best surface for deep edges and curved lines, quick stops and starts, and traction.
If the ice is really thick, which we tend to not like too much, it makes it really breaky and brittle.
Ice on the long track oval is thinner, about 5/8 of an inch. This means the surface remains colder and harder, conditions long track skaters need for a smooth, gliding stride.
One thing that I love about ice skating is the ice is the same for everybody. It's a level playing field and the best is going to win.
For these Olympic athletes, being the best includes conquering the slippery surface of ice.